Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important concepts of logarithmic and exponential functions with examples. And for this, I am using the work of an outstanding and one of my best student, Miss Sayyeda Fiza of class 2020, the Lyceum. An important equation to get A star in all your subjects. Comprehensive concepts plus regular practice is equal to A star. An important advice for me and for everyone. We should be nice to others. Rules of indices. Number 1. To break the given power, multiply the terms if the powers have a positive sign between them. For example, if we have 5 to the power x plus 2, so we can break this power as 5 to the power x times 5 to the power 2. Number 2. Break the given powers by dividing the terms if the powers have a negative sign between them. We can write this as a to the power m divided by a to the power n. For example, if we have 3 to the power x minus 2, so this can be written as 3 to the power x divided by 3 to the power 2. Number 3. If a term with a power is itself raised to a power like this, then the powers are multiplied together. This n will be multiplied with m. So we have a to the power m into n. Well, if we have 5 to the power 2x and whole power 5, so this 5 will be multiplied with this 2x. So we will have 5 to the power 10x. Similarly, this r will be multiplied with both m and n. So we have a to the power mr plus nr. Here this 4 will be multiplied with these two, x and 3. So 4x plus 12. Number 4. If the bases have the same powers like this, then we take the powers as common, divide the numbers like this. We can write this as a upon b whole power n. Similarly, we can write this as 2 upon 3 whole power x. Rule number 5. If the bases have the same powers, then we take the powers as common and they can be multiplied like this. For example, if we have 2 power x times 3 power x, we can write this as 2 into 3 whole power x. And then we can write this as 6 power x, which is here. Logarithms. What is logarithm? A logarithmic function is the inverse of an exponential function. For example, if you find the f inverse of this function, then you will get ln x. Therefore, a logarithmic function is the inverse of an exponential function. Well, log, L-O-G, is short for logarithm. On calculator, for logarithms to the base 10, we use the log key. In writing, we write LG. This is same as LOG in calculator. So we write LG and we use log key on calculator. They both mean the same thing. In writing, it's LG. On calculator is LOG. And they both have the same basis, which is 10. And this log is known as common log. For example, in log 5, the base is 10. That is, log 5 is log base 10 function 5. But the formal way of writing this log is this. there is no need to mention the base 10 because it's understood that the base of LG is 10. Application of logarithms. Well, logarithms are used to solve difficult exponential equations such as ax to the power ax is equal to b. For example, this equation. So, where there is no obvious way of writing the numbers a and b in index form with the same base number. For example, in this question or in this example, there is no way to write the number 9 as the base of 2. You cannot write 9 as the base of 2. Hence, to solve these types of questions, we use logarithms. For example, if we have to solve this question, then we would need to use logarithm. So by taking LG on both sides, we have this equation. According to power law, you can bring this x here. So we have x log 2 log 9. Finally, we have x is equal to log 9 upon log 2, and which is 3.17 up to 3 significant figures. You can take the screenshot of this page if you want. Well, before taking log on both sides, make sure the equation must be in standard index form, in this form. If it's not, then use the rules of indices to bring the equation to this form. For example, in this question, this equation is not of this form. So first bring equation to standard form and then take log on both sides. And we can bring this equation into this form with the help of rules of indices. First, we need to simplify this power like this, 3 power 2x times 3 power 1. Then we have to simplify this. 2 power 5 means 32. So we can write this as 32 power x. This will become 9 to the power x. Now we need to bring this 9 to the power x on left hand side, and then we need to take power x common. Now this is the standard index form of this form. So by taking LG on both sides, we have this value of x up to 3 significant figures. So make sure you take log when the equation is in this form. If it's not in this form, then first use rules of indices to bring the equation to this form, like this. We do this to make the calculation simple. Types of logarithms. There are 3 types of logarithms. Number 1, common logarithm, which is denoted by LG. Natural logarithm is denoted by ln, and variable based log, it is denoted by log. An important note, this log is used when a calculator is not allowed in calculations. You cannot use calculator for this type of log. You can use calculator for these 2 types of logs. Common logarithms. Well, logarithms of the base 10 are called common logarithms. It is indicated by LG in writing, and in calculator it is indicated by log key. This log has base 10. You can understand this as this is the base and this is the function, and the base of this log is always 10. We write base here and function here, but since this log has a fixed base, so there is no need to mention this base. You just need to write the function here. So log 5 means log 5 base 10. There is no need to mention the base of log LG. So LG function 5 base 10 is written as log 5. It's understood that the base of this log is 10. Now this is very important. Logarithmic function form. This is the logarithmic function form. To make this form simple, to understand this simple, in a simple way, I have mentioned this base here. Well, this is the logarithmic function form. Index form. Well, index form is used to remove log from the equation, from the logarithmic function form. This is the index form. You can understand this from these two equations. So first you need to write y here. This is the logarithmic form and this is the index form. Now how to get this form? For this form, or to get this form, first copy this function here, copy y here, and make 10 is the base of this x. So from logarithmic function form, if you need the index form, you should copy this y here and you should make 10 is as the base of this x. For example, if we have this thing and if we have to remove log, if the question is find x, then according to index form, copy this x here and make this 2 as the base of this number 3, and the answer is 8. So this is the way to get the index form from the logarithmic function form. Natural logarithms. Well, small e, this means exponential function, and this has a fixed value e power 1. The value of e power 1 is 2.718. Natural logarithms are denoted by ln. So logarithms of the base e are called natural logarithms. They are denoted by ln. And there is no need to mention the base here. You just need to mention the function here. So ln ey is basically ln y. This is the formal way, and this is the way of writing with the base, ln with its base. Informal way, you can say. So ln function is here and base is here. Base is e and function is, let's suppose, is 5. But you don't need to mention e because it's understood that the base of ln is always e. So no need to mention the base of ln. Therefore ln base e function 5 is written as just ln 5. Logarithmic form. So if we need the index form from the logarithmic form, we would need to do the same thing as we did here. Copy this y here and make 10 as the base of this x. Same thing. You just need to copy this y here and then make this e as the base of this x. Y is equal to e power x. For example, if we have ln x is equal to 3. So we can write this as ln x base e 3, then x will be e to the power 3. This is the value of x. Copy this x here and make this e as the base of this number 3. Variable base logarithms. Well, it is denoted by log and is written with the given base. For example, like this: log base a function y. Note, for this type of log, don't use calculator. Now this is the logarithmic form and this is the index form. Do same thing. Copy this y here and make this a as the base of this x. So we have y is equal to a to the power x. For example, if we have this log 2y 4. So we can write this as y is here and 2 to the power 4. So the answer is 16. Well, the conditions for log a y to be defined are both y and a must be positive and a must not be 1. See, they both must be positive and the base must not be 1. So if the base is 1, then the equation will not be verified. See, if we have log 1 5, so to convert this, after converting this equation into index form, we have this. So 5 cannot be 1. So base of log ay, in log ay, it must not be 1. It could be anything, any positive number except 1. And both the numbers must be positive, both a and y, because logarithms are always defined for positive numbers. Some important rules regarding all the three types of logarithms. For common log, log 10 is 1. Why? Because you know in LG the base of the log is always 10. This is also 10. So when both numbers are same, the answer is always 1. You can verify this through calculator. When the numbers are same, the answer is always 1. Natural logarithm. ln e is 1. Why? Because in ln e, the base is also e. So since both numbers are same, the base and function, so the answer is always 1. Like this. An important property for natural logarithm. If we have e power a ln b, so the answer will be b to the power a. This a will come here according to power law, and then we have b to the power a. For example, if we have e power 3 ln 2, so this will become 2 cube. This 2 will come here and this 3 will become the power of 2. You can verify this through calculator. For variable based logs, there are two important rules. Number one, same numbers, answer is always 1, like here and here. But for this second rule, make sure this number must be 1. And this could be any number except 1. Any positive number except 1. The answer will always be 0. Why? Because if you will get the index form from this form, you will get this. 1 is here, 2 to the power 0, 1 is equal to 1. So you can verify this rule through this example. So when the numbers are different with 1 as the function of log, the answer is always 0. This is only in variable based log. The third rule, since base cannot be 1, therefore this log is invalid. Well, when the numbers are different in common and natural logarithms like this, 2, because the base is 10, so numbers are different. For example, 3, the base is e. So you can use calculator, and you have to use calculator to evaluate these type of logs. Well, for all types of logarithms to be defined, the functions of the logarithms must be positive. I already have told you that all types of logs are defined for positive numbers only. Means in LGY, in LNY, in LOGYA can only be defined. I mean, in all three logs, y must be positive, and for this log, a must be positive except 1. So make sure you remember this. All types of logs are defined for positive numbers only. And for this log, the base must be positive except 1. The laws of logarithms. Number 1, power law. Well, this is the power law. According to power law, we can make this power the coefficient of log. this b can come here according to power law. So log a power b can be written as b log a. The reverse is also possible. You can bring this b here according to power law. So b log a will become lg a to the power b. It depends according to given situation. So which particular form you need to use. So log 2 cube can be written as 3 log 2. You can bring this 3 here. And you can bring this 5 here. Log 3 to the power 5. Number 2. Product law. When two functions multiply, if two functions are multiplied, then we can distribute log to both the functions with plus sign between the logs. Like this. Log bracket a times b can be written as log a plus log b. And the reverse is also possible, but make sure while writing in while using product law from this form, the coefficients of all logs must be 1. While using the reverse form of this product law, you must check the coefficients of all the logs. They all must be 1. If not, then make them 1 by using the power law. So since we have the coefficients 1, so we can write these two log as a single log in this way, log AB. You can understand this with the help of this example. Express 2 ln 3 plus 5 ln 2 as a single log. Well, first make the coefficients 1. First make the coefficients of these two logs 1. So according to power law, you can write this 2 ln 3 as ln 3 square, and this 5 can come here and it will become ln 2 power 5. Now get the simplified form of this equation. So we have ln 9 and ln 32 because 3 square is 9 and 2 power 5 is 32. Now you have to use this form. So we can write this as ln 9 times 32, which is ln 288. So this is the way to use the reverse form of product law, this form. First make the coefficients 1 with the help of power law, and then you can use the product law, the reverse form of product law, this form. An important note. See, we use product law when functions multiply. Since in this case the functions are neither multiplying, functions are not multiplying, in fact they are in fact adding or subtracting, so we cannot distribute log to these two functions in this way. We cannot write this as log a plus log b, or in case of minus, log a minus log b. So this equation is not right. You cannot distribute log when functions are either adding or subtracting. You can only distribute log when functions are multiplied, like in this case, log a plus log b. Quotient law. We use quotient law when two functions divide, like this. So we can distribute log to both the function in this way, ln a minus ln b. We must have negative sign between the logs. We must put negative sign between the logs. And the reverse is also possible if the coefficients of all the logs are 1 and there is a negative sign. So we can express these two logs as a single log in this way, ln a upon b, a upon b. Express this as a single log. Number 1, you have to make the coefficients of both the logs 1 with the help of power law, like this. This 4 can come here and this 2 can come here. This is the simplified form of this, and this is the reverse form of quotient law. Note, when using product and quotient laws, make sure the coefficients of all the logs are 1. If not, then make them 1 by using the power law, like in this case. We use power law to make the coefficients 1. Well, the combined forms of both the laws, product and quotient laws. So if we have this situation, then we have to distribute log to these three functions in this way. This can be written as ln a. Since both functions are in denominator, so we have to put negative sign, bracket, and these two functions. Since they both are multiplying, so we must have ln a plus ln c, ln b plus ln c. But you can do this directly in this way. You can write this as ln a, and since both the functions are in denominator, so there must be negative sign for both. So minus ln b minus ln c. See, terms which are in numerator are opened with positive signs, whereas the terms in denominator are opened with negative signs. So these two terms opened with negative signs. You can understand this combined form through this example well. Since both are in numerator, so they both are opened with plus signs, and these two will be opened with negative signs like this: minus ln c minus ln d. Express this as a single logarithm. First, make the coefficients of all logs 1 with the help of power law. Bring this 5 here, 2 here, 4 here, and 3 here, and get this equation. Now get the simplified form of this. 2 power 5 is 32, 3 square is 9, and so on. So this log is positive, this is also positive, so you have to write this as ln bracket 32 times 16. They both must be in numerator. This is the reverse of this. And since they both are negative, so their product should be in denominator, like this. And this is the simplified form. Logarithmic equations are used to solve complicated equations. It is essential when solving equations involving logs that all answers or roots are checked in original equation. This is very important. You must check your answers with the original equation. These are logarithmic equations for all types of logs. So for variable based log, if we have same coefficients on both sides, for example 1, and single logs on both sides and same basis, three things are important. We must have single logs on both sides with same coefficients and with same basis. If we have these three conditions, then we can equate the functions of these two logs, or functions of both the logs on both sides. So m is equal to n. But make sure you must not cancel these two logs. You just need to equate their functions like this. You cannot cancel logs. See, if we have log 2 if we have log 2 divided by log 3, you cannot cancel these two logs. If you will cancel, you must get 2 upon 3, but you are not getting 2 upon 3. The answer of log 2 upon log 3 is not 2 upon 3. So you cannot cancel log. This is wrong. So never cancel logs on both sides. Just equate their functions. Now this is the logarithmic equation for common log. So if we have same coefficients and single logs on both sides, we can equate their functions like this. For natural logarithm, same coefficients, single logs, so we can equate their functions. Note, before equating the functions of logs, make sure there are single logs on both sides with same basis and with same coefficients. We already have understood these rules, that same numbers, if we have same numbers, the answer is always 1. ln is always 1, log 10 is always 1. Example of logarithmic equation. Solve this equation. To solve this equation, we must first convert these two logs as a single log. First, we need to express these two logs as a single log with the help of the laws of logarithm. In this case, we will use quotient law. So this will become 5 upon x, ln 5 upon x. Now see, there are same coefficients of the log and there are single logs. So we can equate their functions like this. Now you just need to get the quadratic equation and then use quadratic formula and get the answers. There are 2 answers and 3 significant figures. Now you have to check your answers with the original equation, the one which is given in the question, the one in the question in fact. You cannot check your answer with this equation. Always check your answer with the equation which is in the question. So you can do this mentally if you want. When you will substitute 3.62 here, you will get positive log. And when you will substitute 3.62 here, this is also positive. So logarithms are defined for positive values only. So both logarithms are fine with this answer. So if you will substitute, this is here. So if you will substitute 1.38 here and here, both logarithms are positive. So this is also fine. So both answers are right. Next question. Solve this equation. To solve this equation, we first need to express these two logs as a single log with the help of quotient law, and we need to convert this 2 in the form of log by multiplying ln e with this 2 because ln e is 1. So we can convert 2 by multiplying 2 with ln e. So with the help of quotient law, we have this ln x plus 2 upon x, and this is 2 ln e. Now you have to use power law to bring this 2 here to make the coefficient of this log 1. Now we have same coefficients of the logs on both sides, and single logs are on both sides, therefore we can equate their functions like this. So when we have single logs on both sides with same coefficient, then we can equate their functions. Now multiply this x with e power 2 and then bring this x on right hand side so that you can take x common. This is the exact value and this is the answer up to 3 significant figures. When there is just one answer, then there is no need to check the answer. Question number 3. This question is simple. You just need to bring this 2 here according to power law with the help of power law. So we have this equation. Since coefficients of both the logs are same and there are single logs on both sides, so we can equate their functions like this. Now expand this and equate the entire thing to 0. By solving this equation, we have two answers, x3 and x minus 5. Now we have to check our answer with the original equation, not with this equation. Remember, always check your answer with the original equation, the one in the question. So when you will substitute 3 here, this log is positive, it's fine. When you will substitute 3 here, this is also positive. See, with 3, both logs are fine, so this answer is verified. With minus 5, this log is fine, but this log is undefined. This has become negative, like this. So this equation is not right because logarithms are only defined for positive numbers. Therefore, this answer is not right. You have to reject this answer. You have to mention the final answer. Hence, this is the final answer. So whenever you get more than one answers, always check your answers with the original equation. Like this. You can do this mentally. You don't need to show the working of the inspection. Solving exponential equations. In O levels, you learn how to solve exponential equations whose terms should be converted to the same base. Like this. You can write 8 as the base 2. 2 power x and 8 can be written as 2 cube, so x is 3. And in add math, I have done this type of equations as well. You know how to solve these equations. In this section, you will learn how to solve exponential equations whose terms cannot be converted to the same base. Like in this question, you cannot convert 9 as base 2. So you have to use log. Well, there are two types of equations. Type 1. The terms are neither adding nor subtracting. See, in type 1 equations, the terms are neither adding nor subtracting. This 2 is multiplying, this 4 is multiplying. Or you can say this in this way as well. The terms are either multiplying or dividing or both. So either you can understand type 1 rule with this information or with this information. The terms are neither adding nor subtracting. So in order to solve these types of equations, use the rules of indices and get the standard index form. A power x is equal to b. Get this form and then use logs on both sides. This is the way to solve these type of equations. Let's understand how to solve these type of equations. So example 1. We have to solve this equation. Number 1, the way to solve this equation is to get this index form with the help of rules of indices. So first, we need to use rules of indices to get this standard index form. A power x is equal to b. Number 1, we need to simplify this power. This can be written as 5 power 2x over 5. This is fine. 5 power 2x will become 25 power x. And you have to bring this 3 power x on left hand side. And you have to bring this 5 on right hand side. So when you will bring 3 power x on left hand side, you will get this thing. And here we will have 10. You can take this x common. This is the standard index form. As soon as you get the standard index form, this form, take log on both sides. You can either take LG or ln. It's your choice. So by taking LG on both sides, we have this equation. Now according to power law, we can make this x coefficient like this. And this will be divided on right hand side. This is the final answer up to 3 significant figures. Example 2. We have to solve this equation. Since the terms are neither adding nor subtracting, therefore we will use rules of indices to get the standard index form, this form. Number 1, get the simplified form of this 2x power x minus 3 like this. And the simplified form of this as well. Now bring this 3 power x on, first get the simplified form. So this will become 5 times 2 power x upon 8. This will become 81. 81 times 4, you can check this later. Or you can leave this as it is. Now bring this 3 power x on left hand side and this 5 upon 8 on right hand side to get this equation, the standard index equation. After getting this standard index equation, take log on both sides. This x will come here according to power law then. You can have bracket here if you want. It's better. Now divide this log on right hand side and get this answer up to 3 significant figures. This is the way to solve the type 1 questions. Type 2. In type 1, the terms were neither adding nor subtracting, whereas in type 2, the terms are either adding or subtracting or both, like in this case. In this case, the terms are adding. The terms are adding. How to solve these type of questions? First, simplify the powers and then use the substitution method. Remember, we always solve these type of equation with the substitution method, by using the substitution method. And make sure you substitute the term that has the smallest power, like in this case. You need to substitute this 5 power x as y instead of this 5 power 2x as y. We always substitute the term that has the smallest power. This term has the smallest power, so this should be substituted as y. Don't substitute this power as 5 power 2x as y. This would make calculations very difficult. So in this case, this 4 power x should be substituted as y. In this case, this term has the smallest power, so this should be substituted as y. Now, how to solve these type of equations? See, example 1. To solve this equation, first get the simplified form of this term, 4 power x into 4 square, and copy the left hand side. Now, this 4 power x or this 4 power x should be substituted as y, and you have to mention the substitution, it's compulsory. Let y be 4 power x. So this will become y, this will become 16, this will become y, this will become 16. This is 16y and this is y. When you will bring this on right hand side, it will become 15y is equal to 16. So y is this. But you are working for x. So make sure you must substitute y by 4 power x. This is the standard index form. Now take LG on both sides. And this is the final answer up to 3 significant figures. Make sure you must write your answer up to 3 significant figures. All non-exact answers must be written up to 3 significant figures according to Cambridge's requirement. Number 2. Example number 2 of type 2 question. We have to solve this question. So this term has the smallest power, so this should be substituted as y. So this will become y, this will become y square, and this will become y cube because of power 3x. Now you have to bring everything on left hand side and equate to equation to 0 like this. Now take y common, and we have either y0 or this equation to 0. So with the help of quadratic formula, we can get the answers of this equation. There are two answers, 1.618 and minus 0.6180. Now replace y by 3 power x because we are working for x. When you will take log on both sides, you will get no answer because logs are only defined for positive numbers. So this is invalid. When you will take log on both sides onto this equation, you will get this answer. And this will also be invalid because logs are defined for positive numbers only. This is the way to solve type 2 questions. Well, this is all. An important advice for me and for everyone. We should be kind and we should be humble. Best of luck to everyone. Allah Hafiz.